Welcome to Study Loop.
Okay, so this problem is asking for two things here. The first is to draw two epimers of the erythrose. And two, it's asking us to name these compounds. Okay, so first I'm going to start out by drawing out the molecule d-erythrose. And this is given right in the textbook. So I'm just going to copy it down as so. And this is d-erythrose and not L-erythrose because the hydroxyl group that's furthest from the carbonyl group is on the right side. If that hydroxyl group were on the left side, then this would be L-erythrose. So we are to identify two epimers of this molecule. And if you think back to what an epimer is, it is a diastereomer that differs at one chiral center. So what does this mean? So if we take a look at d-erythrose, and I'm just going to label the carbons along the chain there. So if we take a look at the chiral centers here, which are located at 2 and 3, and those positions, if we swap out one group for the other on either side of those chiral carbons, you come out with an entirely new molecule. It would be a diastereomer. In other words, it would be an epimer to d-erythrose. Okay, so what do I mean by that? So just focus in on the second carbon there along that chain and d-erythrose. Okay. So on that second carbon, if we swap the hydroxyl group with the hydrogen, like so, that is an entirely different molecule than d-erythrose. And in fact, your book calls this d-threose. And this is an epimer of d-erythrose. It's a different molecule, it's a diastereomer. It is not an enantiomer. Okay. And we could do the similar process to the carbon at the third position. If we swap the hydroxyl group and the hydrogen, we are left with this. See, I'm just circling the carbons that we were focusing on. And this is also an epimer of d-erythrose. It is a diastereomer of d-erythrose, not an enantiomer. However, this molecule that we just drew, that is an enantiomer of d-threose, which means we could call this L-threose. Okay. So d-threose and L-threose are enantiomers. They are epimers of d-erythrose. So I'm just going to write that down for clarity. Okay, and L-threose is also an epimer empty erythrose. Okay. And these two molecules are enantiomers of one another. I'm just going to box in the answer that was required to answer this question.